The lesson today is about the Moiver's theorem and the nth roots in the complex polar plane. The complex plane. Let Z be a number in the complex plane. Does Z equal A plus BI, where A is the real part and B is the imaginary part? Coming examples identify the real and the imaginary part of Z. Now Z equal 3 plus 2i, thus the real part is 3 and the imaginary part is 2. When you plot this number, just plot the point 3, 2. Okay, now Z equal negative 2 plus 5i. To plot it, we will say the real part is negative 2 and the imaginary part is 5, and we will plot the point negative 2, 5. Another type of equation that he will give you u equal 1 plus 3i and v 2 minus I, and he will ask you to graph u plus v. All what you have to do, you plot u, you plot v, and you find u plus v, which is 1 plus 3i plus 2 minus I, and you will end up having 3 plus 2i. Thus you will plot at the end the point 3, 2. The absolute value or the modulus of any complex number is basically square root a square plus b square. Okay, find the absolute value for z negative 2 minus 4i. Absolute value is the square root of negative 2 square plus negative 4 square, and the answer is 2 radical 5. Another example, z equal negative 3 plus 4i, and the modulus will be square root of negative 3 square plus 4 square, and the final answer is 5. In the coming section, we will learn how to convert from complex form or rectangular form into a trigonometric form, or we call it the polar form. If you are giving z equal a plus bi, you need to find first of all r, which is square root a square plus b square. Now to find theta, you need to check up the sign of a. Now theta, if a is positive, then theta is tan inverse b divided by a. If theta is negative, then if a is negative, then we say theta equal tan inverse b divided by a, then we have to add 180 degrees. Now after finding r and finding theta, you will say z will change from a plus bi into r bracket cosine theta plus I sine theta. Take the following example. Z equal 2 plus 3i. Now we say r equal square root 2 square plus 3 square, and it will be radical 13. Now to find theta, we check the sign of the real part a, 2, it's positive. Thus we say theta equal tan inverse 3 divided by 2. You find it by the calculator, and the value will be, I'm waiting for the value, okay, 56.31 degree. Now you're not done yet. You will say, okay, my new z equal r cosine theta plus I sine theta, and you apply it as you can see in front of you. So now to another example where a is negative. I'm asking you to convert z equal negative 2 plus 2 radical 3i to a polar form or trigonometric form. R is basically the square root of negative 2 square plus 2 radical 3 square. You will calculate it and find the value, which is 4. Now you need to find theta, but because a is negative, you will say theta equal tan inverse 2 radical 3 divided by negative 2 plus 180. You have to add 180 to find theta. Now z equal r again, cosine theta plus I sine theta, and you replace the values that you found it earlier. The product of two complex numbers, of course, in the polar form. If you have two polar numbers, z1 and z2, then the product basically is r1, r2, bracket, cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2. Please just focus on the rule in front of you. Okay, find the product of 2 cosine pi over 6 plus I sine pi 6 multiplied by y divided by radical 3 cosine pi over 3, etc. Now, from this equation, we can find that r1 is 2 and theta 1 is pi over 6, which is 30 degrees. Also, from the second bracket, you can find out that r2 is 1 divided by radical 3 and theta 2 is basically 60 degrees. Now, to apply the product, you will say, okay, the rule says z1, z2 equal r1, r2, cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2. All what you have to do, replace the values, simplify the question as you can see, and find the final answer. Use your screen and solve this question and compare your answers with mine. The quotient rule of complex numbers in polar form, or the division rule. Given the value of z1 and z2 as you can see in front of you, when you divide z1 by z2, you have to make sure that you will say it is r1 divided by r2. And with cosine and sine, you have to say the angles will become theta 1 minus theta 2. For the next example, you can predict that r equal 10 and theta 1 equal 5 pi over 4, which is 225 degrees. r2 equal 2 and theta 2 equal 45 degrees. All what you have to do, just recall the rule and apply it as you will see in front of you. Solve this equation and compare your answer. The Moiver's theorem. Now, if you are giving z equal r cosine theta plus I sine theta, then z to n will be r to n cosine n theta plus I sine n theta. Take the following example. Find 4 plus 4 radical 3i to the power 6. First of all, we need to convert this one into a polar form. This we say z equal 4 plus 4 radical 3i. R we calculated and it will be 8. Theta, it's, okay, we will say tan inverse 4 radical 3 by 4 is 60 degrees. Now we will go to the rule. He wants r to the n equals 6. Thus we will say r to 6 cosine 6 theta plus I sine 6 theta, and we replace the numbers as you will see in front of you. Pause the screen, solve this equation, and then compare your answers with mine. The nth roots of a complex number. For z equal r cosine theta plus I sine theta, the nth roots has to follow the following procedure: r to the power 1 over n cosine theta plus k 360 divided by n. The same angle will be used with sine, and k will range from 0 up to n minus 1. Example, find the fourth roots of -4, -4i. Now we take z equal -4, -4i. The fourth roots means that n equal 4, and we're gonna find the roots for k equal 0 up from 0 up to 3. Now we convert z from rectangular to polar form. We find r as you can see, and then we will find theta, which will be tan inverse negative 4 divided by negative 4 plus 180. Then we start applying the rules as I said before from k equals 0 up to 3. This, as a starter, we say, okay, the rule says the kth root is r to the power 1 over n times cosine theta plus k times 360 all divided by n plus I for this I sine the same angle. I want you to follow the procedure. This is the rule as I said earlier. Now all what you have to do, you start replacing the k's value. Thus you say if k equals 0, you will find the first root, and it will be 4 radical 2 to the power 1 over 4 cosine 225 plus k times 0 times 360 divided by n, which is 4, plus I sine the same angle. Then you calculate it, you find the final answer. You will repeat the same process when k is equal 1, when k is equal 2, when k is equal 3, as illustrated in front of you. You need to memorize the rule in order to find the roots for all requirements. Like we requested the 4th roots, then you have to use to keep repeating the rule from k equals 0, k equal 1, k equal 2, up to k equal 3. Now pause your screen and solve the following question and then compare your answers with mine. At the end of the lesson, I want to highlight the meaning of unity in complex number. Unity means that z equal 1 times cosine 0 plus I sine 0. This unity means r equal 1 and theta equals 0. Now that was the end of the lesson. Thank you for watching.